Welcome to Get Educare. Today we will learn how the hysteresis loss and eddy current loss of a transformer can be separated with the help of open circuit test. Already we have completed the open circuit test of a transformer in part 1 class. If you miss the class, please go through the video so that we can understand this video also. For separation of hysteresis loss and eddy current loss, we need a voltage source of variable voltage and variable frequency. The ammeter is connected with the series of the transformer, voltmeter is connected across the transformer, and wattmeter is connected so that the power consumption can be easily measured. Now the voltage and frequency of this voltage source is varied so that V by F, the ratio is always constant, is maintained. This is one of the most important portion of this test. That means we have to vary the voltage and frequency so that V by F is always remains constant. Suppose V rated by F rated equal to 230 by 50, that is equal to V0 by F0. Therefore, we can write down F0 equal to F rated by of V rated into V0 into V0. Now, whenever V by F equal to constant is maintained, then we know the hysteresis loss W of H is proportional to F and eddy current loss W of E proportional to F square. Hysteresis loss proportional to frequency and eddy current loss proportional to frequency square. That is hysteresis loss equal to some constant K1 into F and eddy current loss equal to some constant K2 into F square. Therefore, the total iron loss W of I is the sum of iron loss is the sum of hysteresis loss W of H plus eddy current loss W of E. That is equal to K1 into F plus K2 into F square. That is a W of I. Okay. We know this relation whenever V by F is constant is maintained. Now, by varying the voltage and frequency, we point is clear from this test. The voltage and frequency of this voltage source is so varied that the V by F is constant, is always maintained. At this instant, let the voltmeter reading V0, the frequency F0 can be easily calculated by F rated by V rated into V0. Let the ammeter reading is I0 and wattmeter reading W equal to W0. We'll start a low voltage of suppose 30 volt. Start voltage. Then what is the F0 dash? Suppose F0 dash. It is the F rated 50 Hz by 250 volt into 30 volt. For this frequency, for this voltage of 30 volt and for this frequency of, this will be the cancel out, that will be the 5 it was a 6 hertz. Okay, that means for a voltage of 30 volt and frequency of 6 hertz, I take the ammeter reading I0 dash and take the wattmeter reading W0 dash. Then I do the W0 by F. That means here W0 dash by F0 dash. F0 dash. Similarly, the next, suppose I apply a 50 volt. The corresponding frequency is calculated from this relation. That will be the F0 double dash will be calculated from this. For this voltage of 50 Hz and for this frequency of F0 double dash, we note down the ammeter reading of I0 double dash and wattmeter reading of W0 double dash. Then I calculate W0 double dash divided by F0 double dash. Similarly, we increase the voltage and frequency so that the V by F is ratio is maintained. Therefore, for 230 volt, ultimate rated voltage of 230 volt, rated frequency of 50 hertz, we note down the ammeter reading I0, note down the wattmeter reading W0, and then we calculate W0 by F, that is equal to W0 by 50 hertz. Okay. Once the chart is completed, once the table is completed, then from this relation, equation number 1, suppose this is equation number 1, from this relation we can write down W0 equal to iron loss W of I is represented by the wattmeter W. Therefore, W0 equal to K1 into F plus K2 into F square. Since in this test the V by F is constant, is maintained, therefore we can write down this relation. From this, W0 by F will be K1 plus K2 into F. Now, if I plot a graph, W0 by F versus of frequency. Now, this is y equal to C plus of mx equation. That means the graph will be a straight line not passing through the origin. Okay, m is the slope. The straight line, graph will be straight line but not passing through the origin. If I extend the graph, it will cut W0 by F axis at point C. Suppose this point is C. Now, from this equation, this is a constant K1, can be easily find out. This is the K1. The origin is suppose O. Then what I do? I draw a parallel line from the point C. I draw a parallel line of x axis. Okay. Then for rated frequency of 50 Hz, suppose rated frequency of F equal to 50 Hz, I draw a perpendicular line. Let this point is x, the point is y, the point is z. Here yz equal to k1 equal to OC. Here yz equal to OC equal to K1. K1. Now XY, what is XY? The XY will be the K2 into F from this equation. Okay, XY will be the K2 into F. Therefore, what is the K2? What is the K2 equal to XY by of F? That means first I find out K1 equal to YZ. I have first find out K1, then from this relation K2 equal to XY by F, I find out K2. That means for your better understanding, I am again repeating this portion. Okay. For once the chart is completed, for different value of W0 by F, different value of W0 by F versus frequency, I plot the graph W0 by F versus frequency. This, from this equation we can see this is a straight line but not passing through the origin, and from here we see that K1 equal to YZ. YZ can be easily calculated from the graph, and K2 equal to XY by F. XY can be easily calculated from the graph. For a frequency of 50 Hz, we know K1, we know K2. Once we know the constant K1 and K2, from this equation WH hysteresis loss equation, hysteresis loss क्या है? Hysteresis loss equal to K1 into F. And what is eddy current loss? Eddy current loss WE equal to K2 into F square. Okay. From this graph, I am finding out K1 is known, K2 is known. Therefore, you can find out for any frequency, you can find out hysteresis loss WH. For any frequency, you can find out eddy current loss WE. Therefore, you can separate the eddy current loss and hysteresis loss with this test. Thank you.
Let us practice an numerical for electrical engineering GATE 2014 questions. An open circuit test is performed on 50 Hz transformer using variable voltage, variable frequency source, keeping V by F equal to constant to separate eddy current and hysteresis loss. The variation of core loss by frequency as a function of frequency is shown in figure. This is the frequency axis, 0 frequency, 25 Hz frequency and 50 Hz frequency. This is the W by frequency axis. This is 5, 10, 15. It's a straight line. Okay. The hysteresis and eddy current loss of the transformer at a 25 Hz frequency respectively are. 4 option is there. You have to find out this. That means we have to calculate the hysteresis loss and eddy current loss at a frequency of 25 Hz. At a frequency of 25 Hz. Okay. Let this point is X, this is Y, this is Z. Okay. As in the theory portion we have learned, this is the YZ. This is YZ. Y of Z equal to K of 1. YZ equal to K1. Now YZ equal to, this point is R, this is O. YZ, therefore RO equal to K1. This is 0, 5, 10. RO कितना है? 10. 10 equal to K1. So I have calculated the value of K1. Again, this is x and y. This is xy equal to k2 into f. K2 into f. I have to find out the value of k2 by using this relation. Now, from this triangle PQR, this triangle PQR, I can write down PQ, this side, by this side, XY, PQ by XY, equal to this side, RQ by this side, RY. The PQ, what is the value of PQ? This is 10, this is the 15. The value of PQ is the 15 minus 10 equal to 5. XY, we have to find out XY. RQ, this is R, this is a Q. RQ is kitna? How much? 50 Hertz. RQ is the 50. RY is the 25. Therefore, what is the XY? XY will be the 5 into 25. 5 into 25 divided by 50. That is equal to 5 by 2. Once I know the XY, I put the value of XY here. That is a 5 by 2 equal to K2 into F. Frequency is the 25 Hertz. What is the value of K2? K2 is the 5 by 2 into 25. That is equal to 1 by 10. I have determined the K2 also. K1 is the 10, K2 is the 1 by 10. Once I know the K1 and K2, then for V by F equal to constant, okay, I know the hysteresis loss equal to K1 into F. I know the eddy current loss equal to K2 into F square. Now, what is K1? K1 is the 10 for a frequency of 25 Hertz. That is a 250 watt. What is the K2? K2 is the 1 by 10. Frequency of 25 Hertz. 25 square. That is equal to 62.5 watt. Answer is 250 watt. Hysteresis loss, eddy current loss equal to 62.5 watt. Option B is the correct options. Okay, please subscribe my channel, okay, and share it, and so that every video can be seen by you. Okay, I will try my best to upload all the videos of electrical engineering. Okay, thank you.